Hey, hi everyone. Hello, warm welcome, a big warm welcome to all of you. Big warm welcome. So here we go. So here we come. Here we continue our journey with the foundation. So we said that we will take the CAT preparation in 3 to 4 stages. We'll start with the foundation, then we'll go on to the intermediate, then we'll go on to the advanced and the reinforcement. Right? That's a kind of the structure that we have decided to take along. Like three or four-fold structure, right? So the first stage we'll go with the foundation. What we do in the foundation stage is we will try and reinforce our understanding from the 10th till whatever we did till 10th standard or 11th or 12th with respect to the maths, right? With respect to the math elements which are important for our quantitative aptitude. So we'll try and consolidate that particular learning because there might be some gaps. It's long time that you might have done till 10th, 11th and 12th kind of math, and there might be some gaps. We will try and plug those particular gaps. While we are trying to plug, certainly we will also look at some of the simple application which appeared in exams like CAT, ZAT, IIFT. We will also take some of those examples. Yes, but nevertheless, the whole idea of the foundation, that's for about next 1.5 months, could be to do with primarily to do with trying to reinforce our understanding from the high school. That's what we are trying to consolidate, right? Yeah. So on that particular note, so here we go. Let's get started on this. Hi Nazia, good to have you here. Good to have you here. How is your health? Are you good? Yeah. All right, so let me quickly introduce myself. I'm Belvi Srinivas. I've been working in the test prep industry for the last 14 years, that is since 2007. Yeah, and I worked in various capacities with the different organizations, as you could see on this particular slide. And so while I was trying to work, I also developed some good understanding and expertise to train the students in the space of QA, DI, and LR. That's briefly about me. You can see the credentials on this particular deck, a brief credential out here. Yes, so how do you reach out to me? You can use one of these Telegram channels. Using one of these channels, you can reach out to me. Quickly, you can reach out to me for any short concerns that you have, or you have a brief counseling. So you can always reach out to me. Not only I, there may be a few other students as well. There could be certain amount of peer learning as well when you are on to these particular on this particular channel. Okay, if by chance anybody here who is technically getting into the P school in 2022, in the sense your idea was to prepare for CAT 21, but along with that you are also looking at ZAT, etc. Maybe this lecture is not meant for the CAT or ZAT kind of students, but nevertheless, if you are here, before you wind up, just a quick announcement on the Christmas Youth that is on 25th of December at 12 in the afternoon. You have a 60 minutes test, so there are about 25 questions from decision making, which is one of the important sections for ZAT. Yes, and you also stand a chance to win Amazon vouchers up to 10,000, right? There are 10,000 vouchers, 5,000, 3,000, etc. You might stand a chance. So if you are preparing for that, you might take a look at this particular test. If you are free on 25th, that is tomorrow, Christmas Day. If you are free at 12 in the afternoon, try and take this live test. Right, yeah. So not only that, on 26th, and along with that, on 26th, you have a mock. There is a free ZAT mock. You get ZAT 20, that's free ZAT mock, which you can take from 9:30 to 12:30. If you are free around that time, this you can take this particular test between 30 and 12:30. Yeah. This lecture is not meant for the students who are appearing for ZAT or they're appearing for SNAP in this coming season. But yes, those who are appearing for these exams from November of 2022, the foundation we are doing the foundation from that perspective, right? So therefore, I'm just giving you as to what is the idea behind these particular sessions. Great, all right. So there we go. So what we were doing in one of the lectures with respect to the divisibilities, we were talking about the questions where we were talking about the divisibility rules. We said that, okay, even before we do this particular question, so let me quickly recap what was the discussion that we had. If there is a number, if there is a divisor, if the divisor is of the form p raised to power n, in the sense the divisors are of the form 2 raised to power n, 3 raised to power n, 5 raised to power n, p stands for prime, right? 5 raised to power n, 7 raised to power n, 11 raised to power n. We talked about the divisibility rules for this, which is technically taught in the high school. Here we examine that, okay, we need to be aware of divisibility rule for 2 power 1, that is 2, 2 power 2 4, 2 power 3 8, 2 power 4 16, and 2 power 5 32. This is all right. We said that from CAT perspective, knowing divisibility rules till 32. We kind of discussed about it. You can go back to that video to understand what are these divisibilities. Here we said that hey, 3 power 1 is important, 3 power 2, that is 3 and 9. Of course 3 power 3 is also important from CAT perspective, but high school stage you might not have come across. We will discuss about that at a later stage. Right, here we also said that from the CAT perspective you should know the divisibility rule for 5 power 1, 5 power 2 is 25, 5 power 3, and then 5 power 4. From CAT perspective till here we should know. I'm not saying that beyond that it won't come. It has not come. That's a point there. It hasn't really come. So from that perspective we can say that, so this is the cutoff number. Yeah, here 7 power 1, so we don't have to go to 7 power 2, but in the high school generally 7 power 1 is not dealt. We will deal about it. What I'm boxing is these are the numbers which we will deal at a later stage. Coming to the 11, you would say that 11 power 1 has been dealt in the high school, that is the 11 solid. That's the sum of the digits of the difference between the sum of the alternate digits. Till this is what we kind of looked at. Then we said that hey, what if my divisors, these are the divisors, right? Hey, what if my divisor is composite, which means my divisor is made up of prime 1 raised to power a and prime 2 raised to power b. In the sense we spoke about hey, what if my divisor looked like 6, that is nothing but 2 power 1, 3 power 1. What if my divisor looked like 72, that is nothing but 2 power 3 and 3 power 2. We kind of spoke about these kind of things where the divisors are made up of multiple primes, then how the divisibility rule comes there, right? So this is the kind of study that we did. You can go back to that lecture which we did 2 days back to understand it a little better. Nevertheless, I'm coming here on this particular slide with just a recap before I get into divisibility algorithm. Right, so I will just do one question built on this, and then we will, today's topic is more to do with the divisibility algorithm. We will get into that particular portion. I would rather suggest that everybody sit with a book and a pen and whatever the little things, because most of it is a high school revision. There may not be too much to learn, but as you listen, if you think that okay, there may be one or two things that are kind of that are kind of slipped your mind, it's a time to recall. Take a book and take a pen and keep writing, scribbling a little bit. That always helps to remember better. Writing always helps you to remember better, right? So therefore don't keep listening, also try and write. Keep a book and a pen always and just keep writing. Not only in this lecture, any lecture where you want to use your time productively, you just have a book and a pen when you sit for the lecture. Fair enough. Let's come back to this question. Given that the number, it's given some 7-digit number. This number is divisible by 7. What is given to us? It is divisible by 7, where a and b are the digits of the number. Okay, this is a kind of a CAT replica question. What we're doing? Find the difference between the largest and the smallest value a can take, where a is a digit. What do you mean by this? A is a digit implies that a takes the values between 0 and 9. Similarly, b is also a digit, means it can take a value between 0 and 9. Right? Okay, now coming to this, now let's quickly understand this. What is the divisibility rule for 11? We spoke about that. 8 5 2 8 2 6 b. Divisibility rule for 11 is start some of the alternate digits starting from the units place. I need to add these folks, right? I need to add these numbers. 8 plus 2 10 plus 2 14. All right, here 8 plus 2, all right, that is 10, 10 plus 2 12, 12 plus b. So b, I don't know what is the value of this, therefore 12 plus b. If b is 0, then sum becomes 12. If b is 1, the sum becomes 13, and so on, right? Therefore you say that this is 12 plus b. Similarly, other side of it, other side of the spectrum, now you start the sum of the numbers starting from the tens place, sum of the alternate digits starting from the tens place. 6 plus a, and then you add 5 to this, and that's it. Therefore you say that this is nothing but 11 plus a. Good. So what is the divisibility rule for 11? Divisibility rule for 11 is u minus t. So that is u minus t. In this particular case, it is going to be 12 minus 11, which is going to be 1, and there is a b minus a, right? Okay, now this is what a unit, sum of the alternate digits starting with the units place minus sum of the alternate digits starting from the tens place. When you do this, you get this. If the number, author has already confirmed, look man, whatever you got now is divisible by 11. What does it mean? This sum should be either 0, or this should be plus or minus 11, or this should be plus or minus 22, etc. and so on. That is when the number would be divisible by 11. For the number to be divisible by 11, I need to get this particular equation to be equal to 0 or plus or minus 11 or plus or minus 22 and so on, right? Okay, let me take the first case here. What is the first case? Let me equate it to 0. 0. What am I interested in? Don't lose focus on what the question is. Question is, hey, why don't you tell the difference between the largest and the smallest value a can take? In the sense, I am interested, there is a variable called a. What is the maximum value of this? What is the minimum value of this? Once I know, I can find the difference between these two numbers, right? Yeah, don't never take your eye from the question. Whatever the process you are doing, you have a set end result. In the sense, you are moving towards something. Sometimes what happens is in the thick of doing the problem, we kind of take our eyes off the question. Never do that mistake. Always have one eye on the question, right? Okay, coming back to this, I need to find the maximum and minimum value of this. Let's take a look at the first part here. Right, let's take a look at this. So what is this? Let's equate it to the first case, which is 0. That is, you are trying to say 1 plus b minus a is equal to 0. In other words, 1 plus b is also equal to a. Okay, what is the maximum and minimum according to this equation? If I take the case 1 equal to 0, what can be the maximum value of a and the minimum value of a? Let me find out from this first case. All right, so if I put b is equal to 0, if I put b is equal to 0, then I will get a is equal to 1. Fair enough. Which means according to this equation, the minimum value of a is 1, because I could not make it 0. Even if I call b is equal to 0, a would be minimum 1. Fair enough. Hey, what is the other alternative for what is the maximum for this? Maximum is, I can write 1 plus 8 is equal to 9. You can't say that no sir, I will make 9 itself as b, then a becomes 10. 10 is not possible, right? Therefore you say that b can be at the most 8, thereby a can become 9. So maxima is going to be 9, the difference is going to be 8. Fair enough. But let us see that what about the second case? Will I be getting a better answer than 8? Because you are now saying that the maxima is 9, minima is 1. But is it possible that maxima is 9, minima is 0, thereby I can get 9 also? This doubt you might get in your mind, right? There is quite highly likely chances that you might get that particular doubt. If you are getting that particular doubt, probably already you can try another case just to ascertain that, okay, will that be possible? Take either 11 or minus 11. Okay, let me take that 1 plus b minus a is equal to minus 11. I just took another case quickly in my mind. From here you would say that, okay, b plus 12 is equal to a. I'm just keeping that variable a on one side so that I'm safe, right? I'm keeping that on one side. So now which implies that a has no value. You may wonder why a has no value, because the minimum value of b is going to be 0. If I give even minimum value of b is equal to 0, then the a would be 12. That's not possible. Okay, so can I increase the value to something? You can't. So therefore you say that, okay, if I take minus 11, I have no solution. You may get it out. What if I take it as a plus 11? A plus b minus a is also equal to plus 11. Fair enough. Pull a on the other side. Now let me write that b minus 10 will be equal to a in that case. Good. B minus 10 is equal to a. So what is the meaning of this particular one? To make a positive, I should make b minimum 10. Otherwise, minimum 10, because a is a digit, it has to be positive. That's not possible because b cannot take a value called as 10. Not possible. And hence you understand that, hey, there is no other case which works in my favor. If 11 itself is not working, then 22 would anyway never work, right? So these are the quick thoughts in your mind that is moving on. And hence you say that, okay, you know that theoretically 9 can be the best answer possible, and there is a choice called as 9. And hence you may get little curious to understand that, is it possible by any chance? So that's where you spend another 30 seconds to understand and work it out a little bit to understand, yeah, it's not possible. You settle with the best difference being 8 out here. I hope it's making some sense to you. So this is kind of examples we did in the previous lecture, right? In the previous lecture we studied about the divisibility rule, and these are the kind of questions that we kind of spoke about, right? What we do now is the divisibility algorithm. Let's go on to the divisibility algorithm on this particular note. Let's take a look at the divisibility algorithm. I hope you are following me what I'm trying to say. Yeah, anybody here for cat 22, cat 23? I guess it's kind of making sense. Yeah, expectation is very clear. It's all going to be at the high school level. It's just a foundation, right? It's just a foundation. Then we will unleash to intermediate, then we'll get on to the advanced, right? Likewise we'll go step by step here. Just by doing the foundation itself, you'll get 80 percentile. That's a reality. In cat, you want to get 80 percentile, your foundation has to be clear. By the time you finish your foundation, you would be getting somewhere about 80 percentile in cat. All right, now that's a kind of percentile you can expect. All right, let's come back to this division algorithm. What does division algorithm means to us? Division algorithm is pretty simple. Here there is a number, there is a divisor, right? There is a quotient, right? And there is a remainder. There may be remainder, can be 0 also, right? This is what it is. So how do I mathematically represent this? You say that number is equal to divisor into quotient plus remainder. This is the division algorithm. Okay, now based on this, there are certain properties I'm going to talk about which you should remember, right? These properties is what is very essential, and you must remember these properties, which is very, very important, right? Because at a larger scale, when we get onto the intermediate stage, the advanced stage, these simple properties will have a huge impact on our problems, right? Therefore, considering that, some of the properties on from this division algorithm we will speak about, which already know which will be used at a mega scale as we go along. Okay, this is the division algorithm, simply to put it to the perspective. Now let me take few examples quickly to illustrate, okay, what does it mean, and some of the simple examples which came in the question, which came in the exam as well, we will try and do them. Okay, let's take a look at this question. Let's take a look at this question. When a number is divided by 5, it leaves a remainder of 4. Okay, this is not to do with any exam question. It's a very, very simple, trivial question. First, I will make my 3 points, and then we will go on to some of the questions which appeared in the exam. When a number is divided by 5, it leaves a remainder 4. I'm reading the question. Yeah. Find the remainder when twice the number is divided by the same divisor. Okay, how do I represent this particular top? There is a number n. When divided by 5 means divisor is 5, because this is what the structure we have. Number is equal to divisor into quotient plus remainder. Division algorithm is in your mind. So for using that division algorithm, you are representing this particular thought. What is the number? I still don't know. What is the divisor? 5. Okay. What is the quotient? Something called x, which I don't know. What is the remainder here? 4. Fair enough. This is my number. So I looked at the first sentence. I represented this mathematically, which appears like this. Good. Next one. Find the remainder when twice the number. Okay. First, let me produce what is twice the number, because there is something called as twice the number. Then we will do the division, etc., etc. First, let's produce the twice the number. What is twice the number? 2n, which means you are multiplying this entire equation by 2, both left hand side as well as on the right hand side. You got to double it. 2n, you say that 5 into x into 2, because you are doubling them. This is 4 into 2. You might have said that, sir, can I write it as 10x there? Or can I write this as 10x? Absolutely, there is no problem. Okay, now this is my new number, because twice the number means it appears like this. What is that author is saying? You please tell me the remainder. You please tell me the remainder when it is divided by the same divisor. What do you mean by same divisor? Same divisor is nothing but 5. Fair enough. Let's go now and divide this particular question by 5. Okay, so you are saying that I will divide this by 5. So this is what the required, the number should be divided by 5. What is the remainder? So you got to divide this by 5. But the point is, it's something, if you want to divide 2 parts by 5, it is as good as dividing each part by 5 and understanding the remainder. If you didn't understand this, take a look at this one. Listen to me carefully. If I have two numbers, 17 plus 19, when divided by 4, you divide this by 4. It is not numerator denominator. Divided by 4, what is the remainder? Right now, these are the two numbers. Now, this is called as isolation technique. What I am talking here is isolation. I call it as isolation technique, in the sense separate the things and deal individually. Right? That is what we mean by isolation technique here. Right, that's what we mean by isolation. So you say that, okay, 17, you divide this by 4, isolation. If there is a plus here, bring that plus back. There is a 19, so you divide this also by 4. List the remainder here. 17 divided by 4, remainder 1. Remainder, right? Yeah. 19 divided by 4, list the remainder, which is nothing but 3. Okay, what is the overall remainder here? The overall remainder, okay, you want to change it a little bit. Probably we'll take 18 to start with, just to prove the point, right? Yeah. 18 divided by 4, 2 is the remainder. Where I am getting this plus from? Because there is a plus here, I am continuing that plus and I get that plus. You say that the overall remainder is nothing but 3. Okay, very simple example that I have taken. What does it mean to us? It means something like this. Instead of adding these numbers, 17 plus 18, which is nothing but 35. 35 when divided by 4, I know that the remainder is nothing but 3. But I don't have to do that. Rather, I can do it in this particular fashion. You may say that, will it work for multiplication also? Yes. Right. For example, had I asked you, hey, 17 into 18 when divided by 4, what is the remainder? You don't have to multiply these two numbers. Instead, use the isolation technique while you are finding the remainders. 17 by 4, figure out what is the remainder. Since there is an into here, since there is an into here, use into in between, and 18 divided by 4, what is the remainder? 17 by 4, the remainder is is 1, 18 by 4 the remainder is 2. Multiply them, your net remainder is going to be 2. Very simple technique, right? This is what is very powerful tool you learn in the high school called as isolation technique while you are trying to find the remainders. Now to put it to the summary, if I were to put this into the summary here, right? So if I were to put this to the summary, yeah, if I were to put this to the summary, you write it like this. If there is a number 1 and there is a number 2 and there is a number 3, when divided by the divisor, please tell me the remainder. So all you do is, hey, you will work in isolation. You would say that number 1 divided by divisor. You will list out what is the remainder. Since there is a plus, you write plus. Number 2 divided by divisor, you will find out what is the remainder. Number 3 divided by divisor, you will find out what is the remainder, right? Isolation. Okay, you may say that, sir, what if there is an into in between them? So in the sense, you now remove this and say that, what if the second sign was into? If the second sign was into, come back and put the second sign as into. You may say that, what if the first sign was minus? If the first sign is minus, come back and put the first sign as minus, right? This is what you mean by isolation technique. Why we are talking about this? Because we are trying to be futuristic. In the future, what your numbers will look really cumbersome. It looks like 23 raised to power 45, right, minus 17 raised to power 16, right, and then you might have that plus, all right, now 283 raised to power 67. They may say that, hey, all of this when divided by 19, what is the remainder? This can be the futuristic question, right? So thinking about this, will I ever be able to add these kind of numbers? No, I will never be able to add and divide this by 19. That's not possible. So considering that future in mind, we are trying to understand some of the properties out here. All right, okay, let's come back to the question. I gave some background here. Just remember this background also. Whatever we try to discuss, remember this background. This background is termed as isolation, technique of isolation. Let's remember this background. So now come back to this. All right, having understood this particular background, let's come back to this particular question. Wherein therefore I am using the isolation technique. I will say that, hey, this remainder is 0. You may wonder why this remainder is 0. There is a 5 here, there is a 5 here, this remainder is 0. Now then you go back to the next one. 8 divided by 5, what is the remainder, right? 8 divided by 5, what is the remainder? 8 divided by 5, the remainder is nothing but 3. What is the sign between them? The sign between them is plus. Therefore, what is the overall answer here? 3. Therefore, 3 would be the answer for this particular question. It is not about cannot be determined. 3 would be the answer for this particular question. Pretty simple question. I'm hoping that you are kind of getting connected with this. It's a very simple question. Maybe when we do another couple of questions, maybe 2 or 3 more questions, you will be able to nail this down properly, right? Let's go to the next one on this note. Let's go to the next one. I hope I'm guessing that you're kind of trying to follow this. Yeah, let's take a look at this. When a number, okay, how do I put this to the perspective? You can remember it like this. When a number is divided by divisor, if it leaves r as the remainder, given this, when a number is divided by divisor, leaves r as the remainder, you can say that when k times the number is divided by the same divisor, it leaves k times of r as the remainder. You may wonder, how is it applicable in this particular question? Think about this. There was a number, you divided by 5, the remainder was 3, right? The remainder was 4. Now k times of the number, that is 2 times of the number, when divided by 5, the remainder has to be 2 times of 4. What is 2 times of 4? The 2 times of 4 is nothing but 8. You are trying to say that it is 8. But the point is, the divisor is what? 5. When you divide a number by 5, you cannot say that 8 is going to be my remainder. And hence what do you say? You divide this by 5 once again and call the final remainder as 3, right? Divide this by 5 once again and call the final remainder as 3. What is that I'm trying to say? When you do this, just in case if k times of r is greater than divisor, divide k times of r by the divisor and find the final remainder, right? This is the algorithm I was talking about. Very important from the high school, right? This point is very important from the high school. If you just remember this, probably you would have solved this particular question maybe in about 10 seconds after reading. You read, 10 seconds is all it takes to process this particular information. Fair enough. Let's come to the second point. Let's come to the second point. Point number 1. I made one particular point. I'm coming to the second point. Yeah, when the number, let's read this together. When the number is divided by 5, it leaves a remainder called 3. Find the remainder when square of the number is divided by the same divisor. Square of the number. Square of the number. Okay, mathematically, if I'm doing it like a high school child, it looks like this. Okay, my number is 5 times of x plus 3. Okay, the square of the number, in the sense, okay, I need to square this whole stuff. I need to square this whole stuff. All right, let me square it. Left hand side n square, right hand side 5x plus 3 whole square. Right, this is what it technically becomes. Square of the number means what? The entire stuff. N square I will do. Therefore, the other side 5x plus 3 whole square also I will do. Now, this is what was given to me and this is what I am arriving at. All right, let's do this. N square, that will become 5 square x square, that is a square, plus 2ab, that is 2 times of 5x and then 3, and then b square, which is nothing but 3 square. Good enough. All right, this is what you wrote. Now, what author is expecting? You now divide this by the same divisor. Divide this by the same divisor and tell the remainder. All right, what is the same divisor? I need to divide this by 5 again, because he said that same divisor. What was my divisor? 5. I will divide this by 5. Isolation technique. Divide this by 5, divide this by 5, divide this by 5. This returns a remainder of 0. Why this returns a remainder of 0? There is a 5 here, there is a 5 here. It returns a remainder of 0. What about this? This also returns a remainder of 0, because there is a 5 here, right? There is a sign plus. I will continue with this. There is another sign plus. Yes. 3 square is what? 9. When 9 is divided by 4, what? 9 is divided by 5. What is the remainder? 4 is the remainder, right? Which becomes my answer. Right. Now, coming to this particular point, listen to this. When the number is divided by divisor, if it leaves r as the remainder, given this point number 2, when the number is divided by the divisor, if it leaves r as the remainder, when a number raised to the power k, when number raised to the power k is divided by the same divisor, your remainder is going to be r raised to power k. Let's understand this. Okay, let's put it to the perspective. Okay, what was given to me? What was given to me was this. There was a number, when divided by 5, the remainder was 3. Good. But author said that when n square is divided by 5, I should know that the remainder has to be 3 square. What do you mean by 3 square? 3 square is nothing but 9. Can I get a remainder 9 when the divisor is 5? Of course not. Therefore, what did you do? You took this particular 9, you divided by the divisor, and you gave the final representation remainder as 4. Right? That is what you gave it as the final representation remainder. Good. So this is what you kind of do here also. When r raised to power k exceeds the divisor, take this r raised to power k, divide by the divisor, and list the final remainder. This is my point number 2 from the high school. Right? Yeah. How your teachers wrote, they might have written little differently here and there. Doesn't matter. After having understood this at the foundation level, this you should remember throughout your CAT preparation. There is no choice in the matter. Throughout the CAT preparation, you should remember them. There are certain things which you have to remember throughout. There is no choice in the matter there, right? Yeah. So there is a new fact. There is a new philosophy. All of these days, the people talk about, hey, don't use your brain to remember. You don't have to use your brain cells for memory, right? They keep telling you that, okay, use your brain for processing, right? If processing the information, don't use it to remember. I don't believe in that, because as you see the decades or from the research, generally the general belief of the science is this: people anyway don't use more than 10% of their brain generally, right? People generally don't use I'm talking about the average and above average individuals. Generally they don't use more than 10% of their brain. Then what is that you are reserving the remaining 90% for? 90% is anyway buffer. So use that buffer to remember also, right? But the new age gurus are advising that, gurus in a sense like in the media, you kind of read that, hey, you don't have to use your brain for memory, right? You just have to use for processing. Boss, that is not the way to crack any of the entrance exam. To excel, you need to be good in memory. You also need to be good in logic, right? Both has to go hand in hand. This new age fads, etc. doesn't help, right? Doesn't help, right? Good. All right, let's move on. Let's go on, right? Let's go on to this. So remember, certain things you have to remember throughout your CAT preparation. There is no choice. That part you please do that. Yeah, let's go on here. Let's go on to the third point. I'm talking about the third point for today. When a number is divided by 5, it leaves a remainder 3. 5 is an example. No, don't think that in the exam, oh, always they will give a 5 man. No, I'm not talking about this. 5 is just to illustrate a point, because I wanted to make 3 points. Just to make 3 points, I took 5 as the number. I'm illustrating those particular points. When a number is divided by 5, it leaves a remainder called as 3. Find the remainder when twice the number is divided by twice the divisor. In the sense, whatever was your earlier divisor, twice that earlier divisor, right? Twice the divisor is twice the earlier divisor. If you want to understand it clearly, I can use that twice the earlier divisor. Fair enough. So how does this look like mathematically? Number is equal to 5 times of x plus 3. Okay, what author is trying to say? He's saying that why don't you double this? Why don't you double this? Good. I will double this 2 times of the number number is equal to 5x into 2 plus 3 into 2, which becomes 6. I made it twice. Right, so now what is happening to my divisor? My divisor is also becoming 10, right? My divisor is also becoming 10 because twice of 5, which becomes 10, twice the divisor. The twice the divisor means 10 is what I'm talking about, right? Okay, 10. So therefore I need to divide this by 10. I need to divide this by 10. Hey, there is a 5 into 2, which is 10. Therefore this returns a remainder of 0. There is a plus here. I will write it. 6 divided by 10. The remainder is nothing but 6 itself. Therefore the answer for this, I think we have to change one of this or one of the answer options. There is no answer option here. For the time being, let us change this to 6 and say that 6 is the answer for this particular question, right? 6 is going to be the answer for this question because you made it twice the divisor. Now listen to this. Hey, how does it look like? Okay, if there is a number when divided by divisor leaves r as the remainder, then when k times the number is divided by k times of the divisor, still the remainder is going to be k times of r. Don't get confused. Don't get confused. Earlier we said that when the number is divided by divisor, if it leaves a remainder r, when k times of the number is divided by divisor, we still wrote k times of r. Now I am saying that, hey, here we brought this k once again here, right? Now we are putting this k here also. So you may don't think that, okay, k and k will get cancelled. No man, k and k gets cancelled is called as that's nothing but simplification. I am not talking about simplification here, right? Let's not simplify this. I'm talking about k and k getting cancelled. No, don't cancel. Divisors, numbers, you don't cancel them in the division, right? So you have to retain them as it is. So it becomes k times of the remainder. Take an example. Let's take the same example here. When the number is divided by 5, it left a remainder called as 3. Alright, when 2 times the number is divided by 2 times the divisor, that is 2 times of 5, your remainder has to be 2 times of earlier remainder, which is 6. Okay, is this 6 less than this 10? Answer is yes, this 6 is less than 10, which becomes the answer for this particular question. Change one of the answer options to 6, which becomes this. Okay, now 3 points I made. This was my third point, right? This was my third point. What was the third point? When the number is divided by divisor, if it leaves r as the remainder, k times of the number divided by k times of the divisor, it leaves a remainder which is k times of r. Now these are the 3 important properties that I wanted to discuss. Now let's go to some of the applications which have kind of come in the exam. A simple exam or a simple applications that would have come at the level 0 kind of applications. Let's try and take a look at them. Okay. Snigdha is trying to ask any ZAT classes. No. Answer is no to your question. Yeah. All right. So here we come. All right. So here we come. All right. Now that's about this. Okay. Let me do quick announcements. Then we will get on to the application questions. Let's go on to some of the application level questions. Yeah. There are some new batches set to launch on Christmas Day. They're all structured courses. They're all structured batches in the sense you want to understand what is this particular batch. This batch is named as weekend morning batch. You want to understand something about this batch. There will be a brief videos made by these faculty members saying that how they want to teach each area in space of quant. Are they starting from level 0? Are they starting directly from level 1? Or are they looking at level 1, both level 0 and level 1, or level 1 and level 2? Every course has an objective, right? Now before you follow that batch, you can always read little bit about that particular batch. There will be a small 3 minutes video, or each of them might have made 2 to 3 minutes video, about 10 minutes. Listen to the 10 minutes of video. It will give an understanding as to what are the objectives of that particular batch. Every batch has different objective because there are different kind of learners, right? Based on different kind of learners, there are different objectives. Similarly, there is a emerge batch, because sometimes you may be wondering, say, why so many batches? There is something here, there is something here. Why every week some batch starts? So every batch need not be dealt in the similar fashion, right? Because there are different kind of learners. You can take and follow a particular batch which suits your learning requirements, right? Because sometimes may be very good at reading, some students may be very good at reading. So therefore you want to do the advanced levels of RCs, or at least the intermediate level of RCs. You really don't want to start with the basic level of RCs. But some of us may not be good readers, right? Good readers. So naturally we might have to start from the basic level of of RCs. So you might have to follow a batch which starts from the basic level of RCs, or otherwise at least the emphasis lies on the basic level of RCs, right? So that's a point there. So you have different kind of batches, and there is a Sunrisers batch as well which started just about a couple of days back. You can take a look at them. So whatever suits your requirements. Always listen to that videos first. Everybody would have made 2 to 5 minutes of videos, so therefore you might have to listen to that 10 minutes of video before you understand what you want, how do you want to follow that particular batch. But however, all structured courses come with a subscription fees. You might have to buy a subscription. There are different types of subscriptions, whatever suits your requirement. You can buy some of these subscriptions. Whenever you use an educator code, this is my code Belvi100, you don't get 100% discount, you get 10% discount. Whenever you use an educator code, you get 10% discount on this, which means this might cost at the end somewhere about 15,000 rupees, this might cost somewhere about 20,000 rupees, and so on, right? You get 10% discount. Although the code says 100, you don't get 100% discount. Don't blame me for that. That's what it is, right? But my preference could be always go for the iconic subscription. There are two types of subscriptions. The previous one is called as the plus subscription. This is called, the other one is called as the iconic subscription. My preference is always the iconic subscription for a simple reason. Interactions with some of the educators of your choice is definitely going to help, right? So here you get 25 one-to-one interactions based on your agenda, not our agenda, it's your agenda. You set the meeting. The 25 meetings can be set in 6 months. If you buy a 6 months iconic subscription, you can set up 25 one-to-one meetings. You and the educator, you can discuss, right? Now with different needs. Probably those who are starting now, you want to get your prep calendar for the month of January. How my prep calendar should look like. Your prep calendar depends upon your strengths and weaknesses, how far you have come, because you are already a product of 20 years. In 20 years, what all happened with respect to skill areas? Three major skill areas we are looking at. One, we are looking at verbal ability, that is more to do with the reading. The second, we are looking from the quantitative ability. Third, we are looking at the logical ability. In these three abilities, how far you have come in 20 years time. Based on that, your prep calendar looks different from some other person's preparation calendar. Second thing, it also depends on your exam seasons, your work calendar, in the sense if you are working in the office, if there are a lot deliverables in the month of January, your prep calendar looks different. You can discuss that. One of the agenda, so technically 6 months have about what, 25 weeks, 6 months have 25 or 26 weeks. Every week you can discuss one, or every week you can kind of discuss with every week you can set up a meeting with your mentor and you can discuss week after week. You can look for the update. It can be a prep calendar, it can be the doubts from your concepts, it can be doubt from the lectures that you have been taking, whatsoever it could be. Now at some stage you will say that, hey, now this is a stage of writing the mocks. What should be my mock strategy? Once you write 4 or 5 mocks, make an Excel, present that particular Excel, check it out from where the scores can be improved, etc, etc. Different things, or different meetings might have different agendas, right? Then you reach a stage where you'll be like looking at the filling the forms. Sometimes they ask for statement of purpose, etc. You can validate it with one of the educators, with your mentor. At some stage you want help on the interview front, or at some stage you want to improvisation on your profile front. All these meetings you can set up. Every meeting can have a different agenda and you can discuss what is in your mind. This is the major benefit of iconic, which is definitely going to help. When you look at the future opportunity cost from your next 30 to 40 years of your professional life, it is worth it. Trust me, having these discussions, one-to-one discussions help, right? It's not a herd, all right? It's not about a herd interaction. It is one-to-one, very specific, because every individual is a little different. That is what I've seen in my counselings, right? This would definitely help. Fair enough. So on these on these subscription fees also, you are going to get 10% discount. Whatever the prices that you are seeing, you get 10% discount on this as well whenever you use an educator code, already including my code, which is Belvi100. Fair enough. All right, now here you get 50 one-to-one interactions. If you go for a 2-year subscription, you will get 100 one-to-one interactions. Not just that, there is an offer going on. Just now I said that, hey, you get 25 one-to-one interactions. It is not 25 in 6 months period. It is 35 for now, right? Similarly, just now I mentioned that if in annual subscription, there are 50 interactions, not 50, 70. Trust me, guys, 35, 70, these are too much of interactions. All right, these are actually, right? If you can actually avail that kind of one-to-one interactions, it will really transform. That's my word. Take my words. All right, back to the lecture. Let's come back to the lecture on this note. Let's come back to the lecture. Hey, hi. Somebody by name motivational speaker is trying to say hi. Hi, man. Hi. Yeah, let's come back to this. One of the kind of little closer to the cat kind of questions. Not really. So next couple of questions will take us out there. Let's take a look at this. A number when divided by a certain divisor leaves a remainder of 9. When the twice the number is divided by the same divisor. The point here is what? I don't know the number. I don't know the divisor also. Earlier at least there was a 5 which was there as a divisor. Here there is no divisor also. The remainder seems to be 5. Therefore the question is, why don't you tell me what is the divisor going to be? Alright, yeah. When twice the number is divided by this. Alright, let's take a look at this. How do you write this? When the number, I'm writing in the modern form. I'm writing in the modern form because I already gave 3 points there. Let us write in the modern form. Number when divided by divisor leaves 9 as the remainder. So that's the first statement. Certain divisor. Do I know the number? No. Do I know the divisor? Of course no. What is the remainder? 9. All I know is what? The divisor is greater than 9. That's it. Only one thing I know is my divisor is greater than 9. Because if the remainder is 9, the divisor has to be naturally greater than 9. There is no choice. Only that much I know. The divisor is greater than 9. It can be 10, 11, 12, 13, whatsoever it could be. Good. So then what he says? When twice the number is divided by the same divisor. I'm just writing in the modern style, right? Modern style, just now what we discussed. Twice the number divided by the same divisor. What do you expect? You will expect 2 times of the remainder because you doubled it. If you double the number, you will expect the double of this, which would become 18. But what is author trying to say? He is saying that no man, the remainder is 5. Oh, okay, there is a change. The remainder is 5. Why did this happen? Because 18 has to be greater than divisor. This happened because 18 is greater than divisor. In that case, what you would have done? You would have looked at this 18. You would have divided this by a divisor to get 5 as the remainder. Good. So therefore, what can be one of the values of the divisor? One of the values of the divisor is 18 minus 5, which is equal to 13. That has to be one of the values of the divisor, right? Because, so look at this, 18 when divided by d, the remainder has to be 5. Now subtract the divisor from the number, so you will get this. Okay, if you want to write it mathematically, 18 is equal to d times of x plus 5. Good. What is d times of x? D times of x is equal to 18 minus 5, which becomes 13, which means product of two numbers is equal to 13. Since 13 is a prime number, it should be 13 into 1 is equal to 13. The divisor has to be 13. Remember, it is not quotient is 13. Divisor has to be 13. Hey, why divisor has to be 13? Because man, I said the divisor has to be greater than 9. So there is only one possible value for the divisor, which is this. In other words, quickly to interpret it from here, you would have just looked at these two pieces of information. You would have looked at this 18 and 5, subtract them. You say that one of the values of the divisor has to be 18 minus 5. This is 13. Since this is the prime number, that is the only value divisor can take, which is greater than 9. I'm hoping that you are kind of following what I'm trying to say here. You must be able to follow this. Okay, yeah, that puts us to the perspective on this particular question. Simple one. So I've just took the modern style of writing. This is the modern means just now we learned to write it. Instead of writing it n is equal to d times of x plus 9, 2 times of n is equal to dx times of 2 plus 9, 2 times of 18. This is equation style of writing. I'm not saying that, hey, is this fine or is this fine? Doesn't matter. I'm just trying to give you a practice on this. It really doesn't matter. You can write the first style or the second style. This is the style which you generally learn in the school, right? This is the style you learn in the school. This is just a modern way of representing the same thought. Which way to write? Choice is yours. Choice is yours. There is no big advantage by writing in one style over the other style. Fair enough. Let's come to the point. Let's come to the next one here. Let's come on to the next one quickly. Let's take a look at this question. Let's take a look at this question. Okay, take about 30 seconds. Just read the question. Read the question to yourself. Okay, yeah, a number when divided, there are two numbers, right? Because another number, there after that comes, there is a number and there is another number, which means there are two numbers. Let's take the first number a is equal to, okay, a is equal to, there is some divisor, some quotient. I'm writing the quotient of x and there is a remainder 10. All I know is what? Divisor is greater than 10. That's the only thing that I know from here is this, because the remainder is 10, therefore the divisor has to be greater than 10. That is the only fact I know about the divisor from here. Okay, another number, second point, another number, let me call it as b. let me call it as b. So therefore what you are trying to say, d, a same divisor was d there. Quotient can be different. I wrote earlier quotient as x, therefore now I am writing the quotient as y. Okay, y. So that leaves me a divisor as what? 12, which means the divisor has to be greater than 12. Earlier I said that the divisor is greater than 10, but now I am saying that the divisor has to be greater than 12. Fair enough. Then he says that, hey, but when the sum of these numbers, sum means add, you got to be adding these two equations. Good. That gives me a plus b. So thereby I need to add the other side also, d times of x plus y plus 22. This is what I will be getting after adding. But divide by what? Same divisor. Author is saying that, okay man, after adding you divide by the same divisor, you will get remainder as 5. Fair enough. I will divide by the same divisor. I will divide by the same divisor. Okay, now this returns a remainder of 0. Why? Because there is a d here and there is a d here, therefore that returns a remainder of 0. Good enough. So this has returned a remainder of how much? 5. Who said? Author only said 22 divided by d. 22 divided by d has to naturally return a remainder of 0, because 0 plus 5 becomes 5, because author is telling that it is 5. Hey, what is one of the values of d? Just like I told some time back, 22 minus 5. That can be one of the values of the d. One of the values is 17. Hey, if the 17 is a prime number, since 17 is a prime number, which serves as my answer, because I can't rewrite it in many other fashion. Right, I hope already it is making some sense to all of you. This should have made some sense. Very similar to the previous question, just that he gave two numbers, because so far we were doing with one number. He's shifting the gear. He's saying that I will give you two different numbers. Fair enough, doesn't matter to me. It's all right. All right, this is how we kind of work. All right, let's go to the next one. All right, let's move on to the next one here. Let's move on to the next one. So I will give you about a minute's time. Try and answer this question to yourself. Keep a book, keep a pen, try and answer to yourself. Yeah, there is not a single value, right? There are multiple values that it is trying to take, right? Here we go. When a number is divided by a divisor, it leaves a remainder of 11. Good. Then what he says, say when 5 times, I'm now writing in the modern style, right? This is a modern style. We can write it like this also, number is equal to dx plus 11. There is nothing wrong with that as well. I'm just trying to express in this particular style. Okay, when 5 times the number, okay, that is 5n. When 5 times the number is divided by the same divisor, what is the expectation? If you make the number 5 times, naturally you are supposed to be making the remainder also 5 times. We know this particular property, therefore you say that this is 55, right? You are expecting 55 as the divisor, right? This is what you are expecting in the remainder. Sorry, 55 is the remainder, but author is saying that, man, the remainder is only 7. Good. From the first premise, all you know is what? Look at the first one. Let's understand few things. Whenever you are doing it, when the remainder is 11, implies that your divisor has to be greater than 11. Let's remember this fact, right? Because if the remainder is 11, then the divisor has to be greater than 11. Okay, but in the second case it says that the remainder was 7, right? For remainder was 7. Good. So for remainder 7 means what? You took this 55, you divided this by divisor, and hence you said that final remainder is nothing but 7. Good enough. So let's go back. Therefore, what is one of the values divisor can take? One of the values divisor can take is 55 minus 7, which is equal to 48. That is one of the values the divisor can take, right? One of the values divisor can take is 48. Okay, yeah. So let's come back to this. Let's therefore 48. Therefore, I am asking, find the number of values divisor can take. In the sense what? Divisor can take all the values greater than 11. Number can take, possibility. Can is a possibility. Certainty, what is the divisor? That no one knows, right? That no one knows. Well, there will be one value, but can be possibilities. Can I list? Of course, I can list the possibilities, right? Yeah. So therefore, 48 are all the factors of 48. Look at this 48. Write down the factors of 48, put them in the reverse order a little bit. Okay, 48 is one of the factors. Okay, if you want to write the factors of this, 1 is a factor, just to understand, right? 1 is a factor, 2 is a factor, 3 is a factor, 4 is a factor, 6 is a factor, and so on. That's how you'd be writing. So if 1 is a factor, 1 into 48 is also a factor. If 2 is a factor, 24 is also a factor. If 3 is a factor, all right, then you will say that you would say that 16 is also a factor. If 4 is a factor, 12 is also a factor. If 6 is a factor, 8 is a factor. But the point is, hey, 6, 8 etc. Hereafter it will not matter to me. Why it does not matter to me? Because 6 and 8, they are all less than 11. They are less than 11. I'm looking at only these pictures. In the sense 48 is fine, 24 is fine, 16 is fine, and 12 is fine. These are the 4 factors. Of course, I can write all the set of factors. In fact, this is all the set of factors. I wrote all the set of factors. 48 has these 10 factors. Out of these 10 factors, only these 4 factors are greater than 11, and hence 4 factors out of 10 factors matter. Okay, did you all understand this? 4 factors out of 10 factors matter. Is this clear to you? 48 is fine, 24 is fine, 16 is fine, 12 is fine. Others are not fine. Others are not fine. Making sense? Clear? I guess all of you made sense. The 4 is the answer there. Okay, this is how one of the CAT question kind of looked like, right? So one of the CAT question kind of look like. All right, that brings me to the perspective on today's topic. We talked about division algorithm. I made 3 important points through the course of the lecture. You got to remember those 3 important points, and then we tried to work on, based on those 3 important points, we tried to look at level 0 kind of questions, which also appeared. These last couple of questions also appeared in CAT like exam, right? That's pretty much about it. So try following this. So we will finish the foundation maybe in about 1.5 months time, then we'll go to the intermediate, then we'll go to the advanced, and then we'll go to the reinforcement, right? That's how we kind of plan both the quant as well as the LRDI, right? DIs I will take it at a later stage, because first, once the quant foundation is done, we'll be in a much better position to do the DIs as well. So because we need a little bit of understanding of percentages, profit loss, we need understanding of ratios, we'll be in a much better position to deal with the DIs. But meanwhile, keep doing one thing. Everybody start reading aggressively for 1 hour every day, maybe 2 sittings of 30 minutes each. 2 sittings of 30 minutes each. Put your mobiles to silent mode and do everybody get into the reading habit. Reading is very, very essential when you are looking at a management program in the top B schools. A rigorous, aggressive reading of 30 minutes of 2 sittings minimum every single day is very, very essential. And when you try to read, try and read which is kind of little challenging to you. Try to read a material which challenges your mind a little bit. Don't try to read some novels which are very, very light on your mind. Sure, all right, if you are just a beginner, that's all right. So I have done one particular video, what are the kind of books that you can read for the beginners, etc. I made that. Otherwise, you can start with, if you are already been reading a little bit, try and read some things which kind of challenges a little bit. And along with that, don't neglect to read the newspapers every single day, right? Better go for the physical newspaper. That's a print copies of the newspaper. Less distraction rather than going for the online ones, so that you can actually focus continuously for about 30 minutes on the editorials, etc, etc. Fair enough. That sets me for this particular lecture. So I will see you guys back on Monday. I'll see you guys back on Monday at about 4 p.m. I will see you 4 p.m. on Monday. So all of you have a happy weekend. So I will see you there. Bye-bye. All right, now if you like the lecture, you can always put that like button before you move. All right, you can put the like button there, and then we can, before you kind of wind up on this. Yes, right, that's pretty much about what we are trying to do here. Yep. All right, so any questions, you can quickly let me know here. If there are any questions that you would like to ask, you can kind of let me know. Otherwise, I'm pretty much done for now. Okay, all right guys, I will see you guys back on Monday. Bye till then. Stay blessed. Stay blessed. Ashutosh, there is no particular number to it, right? As we'll progress as we go along, there may be one lecture more, one lecture less, right? I kind of said that in one and a half months we will finish the foundation. Then again we'll do the numbers at the intermediate stage, and again we will do the numbers at the advanced stage, right? That's how we kind of do, right? But the idea is kind of try and do the whole of the foundation in about 1.5 months time, right? By maybe by mid of Feb or so, we should be done with the early Feb or mid of Feb. That's how we go about it, right? Yeah. Cool. All right. All right. Yeah. Okay. So if you want to reach out to me, another way of reaching out to me could be that you can use one of these Telegram channels to reach me, or there could be some peer group you can figure, right? We can also kind of it. Yeah, yeah, all areas we will touch at the high school. That's right. That's right. That's right. All right, guys. Pretty much that's pretty much about today. I will see you guys back on Monday. Bye till then. Stay blessed. God bless you.